See, Lagrange's mean value theorem. This is the second topic of the module 3. Important concept in this unit, one of the important topics in this unit, Lagrange's mean value theorem. First, we are going to see the statement of the theorem, Lagrange's mean value theorem statement. Actually, there are two forms of the statement. First statement, statement, statement of the theorem is if first condition, the function f of x is continuous on a closed interval a comma b. This is same as Rolle's theorem first condition. Second condition, f of x is differentiable. F of x is differentiable on open interval a comma b. Open interval a comma b. This is also similar second condition of Rolle's theorem. In the Rolle's theorem, we have a third condition, but in case of Lagrange's theorem, there is no third condition. Then there exists a point C in between a comma b. There exists a point C in between a comma b such that the derivative of the function at the point C is same as slope of the chord f of b minus f of a by b minus c. The chord joining two points b and a. Geometrically, you observe that this is the theorem statement, Lagrange's mean value theorem. Lagrange's mean value theorem. So first condition is f of x is continuous in the closed interval a comma b. You remember that. Second condition is differentiability, same as Rolle's theorem conditions in the open interval a comma b. Then there exists, conclusion is, then there exists a point C in between a comma b, open interval a comma b. Open interval means don't take the boundary points. Don't, this means a is not included in the interval. This means b is not included in the interval. Open means not included the end point. Then the derivative of the function at the point C is same as f of b minus f of a by b minus a. Geometrically, we see that, suppose this is x-axis. Usually, functions are represented in a plane. Plane means two-dimensional. Dependent variable taken in the x-axis. Here, dependent variable is interval a to b. So, function value, its image value at a, its function value is b, f of b, f of a. That means this point is, by substituting a in the function, we get function value f of a. Similarly, at b, suppose we get a function value by substituting b, x coordinate is b, we get a y coordinate f of b. Suppose uh, suppose this is a curve. Just you feel that I am not good expert in the drawing, so you feel that this is the curve whose domain is a closed interval a comma b. It is continuous curve. That's why it is a continuous function. One more thing, there is no any sharp edges, so it is differentiable. Now you observe that the chord means the line joining a part of a line joining between these two points, between any two points. Here the chord passing through these two points. These two points means a comma f of a, b comma f of b is this line. This line. This is the chord. One more time. I'm properly drawing. Suppose this is a curve. This line is chord. We take point here. B. Right? Now, here corresponding point A, here corresponding point B. So if y value is, by substituting A, we get y value is f of A. By substituting B, is corresponding y value is f of B. Now this is the graph. Chord, this is the chord. Corresponding point is A, comma f of A. The corresponding point is B, comma f of B. So you observe that it is at this point, draw a tangent line. Draw a tangent line. Draw a tangent line. Draw a tangent line. I'm not drawing properly. See, tangent means a line touching the curve at a single point. See, here the curve, the line touching the curve at a point C, whose y coordinate is f of C. This is C. Now these two, you observe that extend this chord line. Chord is a part of a, from here to here. It's called a chord. Chord is a line, a part of a segment of a line. So this line, this is the line. You observe that these two lines are parallel. That means the slope of these two lines are same. Here, at this point, the slope of the tangent line is f dash c. Slope of the upper line is f dash c. Slope nothing but derivative. Derivative nothing but variation of the point. Here the slope is for the below line, chord line. The slope is, chord means variation of the y coordinate. Variation of the y coordinate means f of b minus f of a by variation of the x coordinate. The slope, two parallel lines have the same slope. Slope means x-intercept. The angle which intersect the x-axis, both are same. We extend this, it intersect the x-axis at some negative portion, second coordinate. No problem, but angle is, both have the same intercept. But they different, they intersect the line at different places, even though they have the same angles. These angles are same. That means the slope is same. This is the scenario in the Lagrange's mean value theorem. Now, important thing is how to apply this Lagrange's theorem to solve the problem. So now I am going to solve a problem. Problem 1. Problem. First problem. In the mean value theorem, actually there are two types of mean value theorem. One is Lagrange's mean value theorem, another one is Cauchy mean value theorem. Most of the time mean value theorem means Lagrange's mean value theorem. If we use the Cauchy mean value theorem, definitely we mention the name of the theorem, Cauchy mean value theorem. Mean value theorem means you understand that it is a Lagrange's mean value theorem. In the mean value theorem, f of b minus f of a value equal to f dash c. In the mean value theorem, f of b minus f of a value equal to f dash c into, dash means derivative, into b minus c. because in the previous slide, this is the formula. Take a cross multiplication. B minus A in the denominator factor, move to the left hand side, it becomes B minus A into F dash C equal to B minus A into F of B, F of A. This is the Lagrange's mean value theorem. And the mean value theorem means Lagrange's. They provide the formula also. Determine, determine, determine C lying between A and B. I think it is better to change it. A and B if f of x value is x times of x minus 1 into x minus 2 and a value is 0, b value is 1 by 2. This is the problem. Previous part, other things are nothing. Just they provide the one more time formula, Lagrange's mean value formula. Main thing is this one. Comparing with the Lagrange's mean value theorem, first find the, here our requirement is find C value, f dash C. So before that, simplify in the answer, first you simplify the function. Actually, it is a factorization form, polynomial factorization. Simplify the first you find this two, then this. Here we have three factors. So we get a third degree polynomial, at most third degree polynomial. First one is x square minus x. Simplify the first two left hand side factors, x minus 2. Now, one more time, simplify these two factors. We get x cube minus 2x square minus x square plus 2x. X square into x means x cube. X square minus 2x means minus 2x square. Minus x into x means minus x square. Minus x into minus 2 means minus 2x, which is equal to x cube minus 3x square minus 2x square minus x square means minus 3x square plus 2x. This is the function. Next thing is we need to find derivative because we need f dash c. We required c. Before that, we need f dash c value. That means you find f now its the derivative. F dash x equal to is a polynomial. We can easily simplify. First term derivative is 3x square. Second term derivative is x square. 3 into 2x. Third term derivative is 2 into dx by dx means 1. This is the derivative value. That means 3x square minus 6x plus 2. This is the derivative value. Now we are happy. Already we know the a value. A value is 1, 0. B value is 1 by 2. By using Lagrange's mean value theorem, or we know that by Lagrange's mean value theorem, by using Lagrange's mean value theorem, we know that f dash c equal to f of b minus f of a by b minus a. F dash x value is this one. F dash c becomes 3 into, instead of x, we replace x, c on both sides. We get f dash c. This is f dash x value. We required f dash c. That means replace x with c in the f dash x. We get f dash c. 3c square using this value. Replace with x with c, we get f dash c value. Minus 6c plus 2, which is equal to f of b means f of 1 by 2 because b value equal to 1 by 2. They provide the b value as a 1 by 2. F of a means 0. They provide the a value is 0. B minus 2. Now simplify this expression. 3c square minus 6c plus 2 equal to f of b. Already we know the polynomial. Otherwise, you can take a given polynomial. X into x means 1 by 2 into 1 by 2 minus 1 into 1 by 2 minus 2. X into x minus 1 into x minus 2 minus f of 0 means put x equal to 0 wherever we have a x in the right hand side also. Immediately you replace left hand side as well as by right hand side. Whatever the value you take, you choose as a x. 1 by 1 by 2 minus 0 means 1 by 2. Now simplify this expression and find C. But you choose, here we have a quadratic equation. We get two C values, but our requirement is to find C lies between A and B. If it both may be lies in A and B, we are happy. Both are lies between. Suppose one value lies inside the A comma B and another value may lies between outside of A comma B also. That time you choose only the value lies between A comma B, because there exists a point C between A comma B, open interval A comma B, as per theorem hypothesis. 1 by 2 minus 1 means minus 1 by 2. 1 by 2 minus 2 means minus 4 by 1 minus 4 means minus 3 by 2. Minus 1 into minus 2 becomes plus 2. Here 1 by 2. After simplification, 3c square minus 6c plus 2, left hand side as usual, minus into minus plus in the numerator, 3 by 8 minus 2 by 1 by 8. Now simplify the right hand side expression. Our intention is to find C lies between A and B. 3, 16 by 8, which is 2 by 1. And finally, we get 16 minus 3 means minus 13. Minus 13 by 8, 2, 2 to the 2, 4. That implies 3c square minus 6c plus 2 equal to minus 13 by 4. Take a cross multiplication. 12c square, 24c, 8 minus 13. That implies 12c square minus 24c, 8 plus 30 equal to 0. From this value, 12c square minus 24c, 13 plus 8, 13 plus 8, 21 equal to 0. Mostly 3 is a common factor. 12 is a 12 2 is a, but 27 is there, 21 is there, 3 times. 3 is a common factor, 3 4 is a 3 is a 3 7. So product of two numbers is 0 only when any one of them is 0, but 3 never be 0, so other factor must be 0. Now what about C value? It is a quadratic equation. It has two roots. The roots are the equation is C equal to minus B plus or minus square root of B square minus 4AC by 2 into A. C equal to 8 plus or minus 17. So 64 minus 1 into by 8. I did somewhere mistake. 1 by 2 minus 1 by 2 minus 1 by 2 means minus 1 by 2 minus 3 by 2, 3 by 8 minus 2. Sorry, on the right hand side is C. 0 into anything equal to 0. We made a big mistake here. 0 into anything equal to 0. Not 0 into, we forgot about this 0. We simply minus 1 into minus 2 becomes plus 2, here minus is there. Sorry. So this value is 0. 0 into anything. That's why we get the wrong answer. This is 0. So now here also the right hand side we have 3 by 8 into 2 by 1, which is equal to 3 by 4 only, not all other things. So I erase this thing. carefully you simplify the expressions. Otherwise, we get a wrong answer. In mathematics, especially, carefulness is very, very important. Otherwise, we get all answers. Even you know the procedure, you get the wrong answer. That implies 3c square plus 6c plus 2 value is 3 by 4. Now take a cross multiplication. 12c square minus 24c plus 8 equal to 3. Now 12c square minus 24c plus 8 minus 3 equal to 0. That implies 12c square minus 24c, 8 minus 3 becomes plus 5 equal to 0. Therefore, the root equal to minus b, here 24 plus or minus square root of b square, 24 into 24 minus 4ac, 5 by 2 into 2 into 12, 2 into 12. So now 24 into 24, find the multiplication of 24 plus or minus 24 into 24, 576 minus 12 5 ja, 60 into 4, 240 by 24. Now what about expression value 24 plus or minus 576 minus 240 becomes 6, 3, 5, 2, 336. Is there any factorization possibility between 3 finding 336? Okay, anyhow, we approximately find. If you have a calculator, no problem. Otherwise, you factorize this 336, 2 2 ja, 2 1, 2 6, 2 8, 2 8, 2 4, 2 4, 2 2, 2 2, 2 1. So 3 into 7. This 1, 2. So it is 24 plus or minus. We take 4 as a common factor, 21 by 24. 4 is, you take a 4 common, plus or minus 6 plus or minus root 21 by 6. What about root 21 value? 25 root 25 value, 21 is less than, you think every time. 16 less than 21 because we know the square root of 16, but we know the root 25 square root. Take a square root, inequality does not change. 16 less than 21 less than 25, you know. Take a square root, inequality also does not change. 4 less than root 21 less than 5. But 21 is near to 25 because 4 numbers only difference. For 16 to 21, it is also near to approximately in between 4 comma 5 in between average. Average means 4.5 around. So 4 plus or minus, you take 4.5 by 6. If you have a calculation, no problem. Otherwise, you can do yourself manually in this way. Here we have one root is 4 plus 4.5 by 6. Another root is 4 minus 4.5 by 6. This is 9 point, sorry, 10.5 by 6. This is 6 minus 4.5 means 1.5 by 6. So see, this factor simplification 6 1 ja 6 1 ja. 4 is left. 45, 7, 42, something. 1.7 something. 1.7 something. Here, 6 1 is 6 0. 6 2 is 3. 6 5. But you see, this is not in the interval 0, comma 1 by 2. A, comma b value is A is 0, b value is, but this value is lies between 0, comma 1. 0, comma 1 by 2. A, comma b value. Therefore, our C required C value is, therefore, C value is 0.1,5. This is first problem. Second problem. Second problem, some more difficult than the first problem, but important one, comparing with the first problem.